Then shall we start? Question? The first question I suppose take is people in your tutorial, question number 15. Question number 15, right? Question number 15. Right. Read this question number 15. There you are given the vertices A, B, and C of a triangle have position vectors simple A vector, comma simple B vector, and simple C vector, respectively, relative to an origin O. The point P is on BC such that PB is to PC ratio is 3:1. The point Q is on CA such that CQ is to QA ratio is 2:3. The point R is on BA produced such that BR is to AR equals 2:1. The position vectors of PQ and R are simple P vector, simple Q vector, and simple R vector respectively. Show that Q can be expressed in terms of simple P vector and simple R vector, and hence or otherwise show that PQR are collinear. State the ratio of the lengths of the line segments PQ and QR. Right, people? Okay. First thing is draw with this diagram. First, read the question again, people, and try to draw this diagram. Don't wait till I draw the diagram on the board. Just try, people. Sometimes you might go wrong. Never mind. Going wrong means that's a good message you will get. Why? At least you know I'm wrong. I went wrong. That means you get the idea that once I do some things, there's a chance of going wrong. At least you must understand that. Some of the students, they don't know. They think that they can, right? At least you know that you can or cannot. Yeah, first read the question, people, draw this diagram. Yeah, I'll give 2 minutes. Yeah, the vertices A, B, and C of a triangle have position vectors, simple A vector, comma simple B vector, and simple C vector respectively, relative to an origin O. Suppose this is our triangle. The position vector of the point capital A is simple A vector. That of B is simple B vector. That of C is simple C vector given. Point Q is on CA. CQ is to QA equals 2:3. CQ QA 2:3. Here we have Q. The ratio is 2:3. Point P is on BC such that BP is to PC 3:1. We say. The ratio is that 3:1, people. Okay. The position vectors and R is on BA produced. RA capital R is on BA produce. BA produce means what, people? BA produce means we have to extend this line BA. Then R lies on BA produced such that BR is to AR. 2:1. So if I write this as a ratio, this is BR 2 units. BR. If BR 2 units, AR 1 unit. If I take somewhere here, people, point R, that point R should be not in between AB. Point R should not be in A and B. Why? We are given there the point R is on BA produced, extended BA, BA produced. BA produced means first we have to come to this A, from there we have to draw the line. BA produced means that. What is ratio? BR is to AR 2:1. That means what? When B to R, the length is 2 units, then A to R, the length is 1 unit. That means, people, this A should be midpoint of BR, no? Is it clear? That means if the length from B to R is 20 centimeters, then A to R 10 centimeters. That's the meaning of this. Understand? Right? 2:1 means if this BR length is 20 centimeters, AR length is 10 centimeters. B to R 20, A to R 10. That means, people, B to R 20, A to R 10 means A should be the midpoint. Understand? That means we can see BA is to AR ratio is 1:1. Why? BA length and AR length being equal. If the lengths are equal, ratio is, people, 1:1. Understood? Right? Yeah. So now that is how we understand that given information. And, people, we are given this position vector of the point P as simple P vector. Position vector of the point Q is, people, simple Q vector. And that of capital R is simple R. Understood? Okay. Right. Now, in this case, I am going to find this position vectors of the points capital P, capital Q, and capital R by using the ratio theorem. Right. So I use the ratio theorem, people, to do this question in the least time. I told you that at the examination we don't use the ratio theorem. Okay. Right. Without using ratio theorem, really, the results that we are supposed to take using the ratio theorem we can obtain. That's a simple thing. What's that, people? When we need to find this simple P vector, we can write BP PC ratio, right? It's 3:1 now, right? That's it. Then, right? Then, people, will write like this. The result coming by the ratio theorem can easily be obtained by using in the other way also. That way is nothing but when we prove the ratio theorem, what is the method we use? The same method, right? Yeah. So then we can write this, BP divided by PC is equal to 3:1, right? Then BP is equal to, use the cross multiplication, 3 times PC. You know BP and PC, right? See here, when you move from B to P, this is the direction. P to C, this is the direction, right? Okay, so then same direction, no? And then, of course, we can really put on both sides what? Vectors. We can write this implies BP vector is equal to 3 times PC vector. Even how to write the this vector by using the position vectors of the point P and B. Second letter position vector minus first letter position vector, no? Then it is simple P minus simple B, right? 3 times simple C vector minus simple P vector. We need to find the simple P vector, no? Right? That is the position vector of the point capital P, no? So then we'll take this B to right hand side, and this minus 3P we can bring to left hand side. First we'll remove the bracket on the right hand side. 3C vector minus 3P vector. Bring this to this side, bring this B to right hand side. Then once you bring this to this side, that will be plus 3P. With this P, it is 4P. And take this to the right hand side, B plus 3C, and divide this by 4. What do we get? B plus 3C divided by 4. This is a simple P vector. People, now you can very clearly understand when we use that ratio theorem here to take this answer, the position vector of the point P, how to take that? This ratio times other side position vector 3C, right? This one, plus 1 into B. See, 1B we have, divided by sum of the ratios 3 plus 1. It's 4. It's 4, right? People like that. Find this simple Q, right? And this R we have to find, right? Find that simple Q and simple R. Though you use the ratio theorem, you can, of course, in this case, we can take the answer, no? Right. Right. So then, again, if I write people the simple Q using the ratio theorem, without using the ratio theorem, you know how to take that. This way, you can write the steps, okay? Thereby, you can obtain the same answer that used by the ratio theorem. So then, to find this Q and R, I will directly use the ratio theorem to save time, right? So then, how to take that, people? Simple Q is now equal to what? 2 times A plus 3 times C divided by 2 plus 3, right? No, 2 times A, 2 times A plus 3 times C divided by 2 plus 3 is nothing but 2A plus 3C divided by 5. Q is this now, right? 2A vector plus 3C vector divided by 5. Right. Now, like that, people, simple R we need to find. How to find simple R? Yeah, we'll write this middle. A is the midpoint, no? The position vector of this capital A, we write using the position vectors of this capital R and B and this 1 and 1 figures. Then you will get simple R. That simple R we have to subject by that. That's what we have to do to get the position vector of the point capital R, right? Take that, people. Okay. The position vector of the point capital A, we can write how? It is simple A, no? Simple A vector is equal to 1 into simple R vector plus 1 into simple B vector divided by 1 plus 1, right? This way. 1 into simple B, 1B. 1 into simple R, 1R divided by 1 plus 1. A equals B plus R divided by 2. Use this way, people. Come on. Cross multiplication. 2a equals b plus r vector. Then take this to this side. 2a vector minus r is equal, b is equal to simple r vector. 2a minus b vector. 2a vector minus simple b vector is equal to r vector. So therefore, this implies what, people? Simple r vector is equal to 2a minus b. The three vectors we found. Right. These three vectors we found, people, right? That I think you can very clearly understand. Okay, now next part. Show that simple q vector can be expressed in terms of simple p vector and simple r vector, and hence or otherwise show that p, q, and r are collinear. All right. Okay. Then now I'll use this way. Right now. Okay. Sudden disturbances may occur. People don't leave the class, right? Okay, now you could understand this one. I used the cross multiplication for p vector is equal to b plus 3c, right? So therefore, this equals this means this equals this. This implies b plus 3c is equal to 4p vector. I'll take this as number 1. Okay. And also, people, we have this q vector. Q vector is equal to 2a plus 3c divided by 5, no? Right? Okay. Then I use cross multiplication this way. 5 times q is equal to 2a plus 3c. Okay. Then this gives us this vector 2a plus 3c is equal to 5q vector. This number 2, people. And by this also, we have subjected that one. R is equal to 2a minus b. This is number 3. All right. This is number 3. Right. Now, people, you must do another simple thing. What's that? I write these 3 equations together for our convenience of handling them. Right. 1, 2, 3, the three equations I'm going to write together. All right. First one is B plus BC equals 4P vector. Number 1. Okay. Number 2, people, is 2A plus 3C is equal to 5Q. It's number 2. And this R equals 2A minus B, people. R equals, this means this equals R, no? That way I'm going to write, 2A minus B is equal to R vector. This is number 3. Okay. Yeah. Now we are asked to write this so that Q can be simple Q vector. That means this can be expressed in terms of simple P vector and simple R vector. That means this Q vector should be written only in terms of simple P and simple R. Simple P and simple R. That says, by using these three equations, we have to obtain an expression for this Q. It should contain only simple R and simple P. That means simple A vector, simple B vector, simple C vector should be removed. Can somebody tell me, by using these three equations, how to remove simple A, simple B, simple C vectors easily in order to obtain a relation involving P and R for vector simple Q? Yeah. Yeah, people. How to take? Shall I do something like this? Yeah. We can do like this, people. Here, if I add this 1 and 3, what happens? This is minus B, this is plus B. Simple B later will cancel off. Then what do you get there? 2A plus 3C. Because this and this will cancel off. This 2A and this 3C will add. 2A plus 3C. That, from that we subtract number 2. This way. 1 plus 3 minus 2. See what happens? 1 plus 3. 1 is B plus C, and this is 2A vector minus B minus, right? I draw that here, people, B plus 3C, 2A minus B minus 2, 2A plus 3C. Now you might ask, how do we think like this? Don't ask those questions, people. They are very primitive questions. Now you might say, don't say like that, sir. You are what a person. We are a small child. People, this is a nice example I have. I think nearly 10 or 12 years back. One of my friends, he was to buy a new vehicle. That occasion, I had a small car. Just before, now, suppose now, tomorrow or day after tomorrow, he is going to buy the car. One day in the staff room, when we have the tea break, he was asking from me, Machan, koi vela with me, first gear එක දාන්නේ. වාහනේ යනකොට. He is asking how, no, when we should put the first gear. Then people, that occasion really, without knowing anything about the vehicle that is asking, I told him, ඔය ප්‍රශ්නේ අහන්න එපා. උඹට යම් දවසක ලැජ්ජ හිතේ වාහනේ පදින්න ගත්තාම මේ ප්‍රශ්නේ මං අහුවනේ කියලා. ඒත් එක්කම වාහනේ අරගෙන උඹට පැය දෙකක් යනකොට ගියර් එක දාන්න එක කාගෙන් ඇහුවේ නැතත් උඹට දාගන්නත් පුළුවන් වෙයි. ඒ නිසා ඔක අහන්න එපා කියලා මං කිව්වා. ඒකයි මගේ උත්තරේ. ඒ වගේ ඔයගොල්ලෝ අහයි දැන් මේ මෙහෙම ABC අයින් කරගන්න සර් අපි හිතන්නේ කොහොමද කියලා. ඒක අහන්න එපා ළමයි. තව මාස දෙකක් යනකොට අයියෝ මම මේ මෝඩ ප්‍රශ්නේ අහුවනේ කියලා ඔයගොල්ලන්ට හිතේ. ඕක හරියනවා ටික දවසක් යනකොට. මේ වගේ මැනිපියුලේෂන්ස් කැල්කියුලේෂන්ස් ගන්න හැටි ඒ ඔටෝමැටිකලි අහු වෙනවා ඔයගොල්ලෝ. ඒ නිසා මේක කරගෙන යන්න ඕනේ ඉතින් අර ගියර් එක දානවා වගේ වැඩක් තමයි ඔකට. Right? Okay. Right. So then people 1 plus 3 come in like this. 4p plus r. 4p right hand side we have read no plus r and minus 5q. Right. Okay. Now this b vector and this minus b vector can cancel down. 3c plus 2a remove the bracket minus 2a minus 3c is equal to 4p vector plus r vector minus 5q vector. Okay. Now these two vectors we can cancel down. 3c minus 3c also we can cancel down. Even after cancellation, what is remaining is left hand side. You might say 0. No, not 0. 0 vector. If you put like this, only 0. That's wrong. Why? Then 0 equals, on the right hand side we have a vector. No? 0 is a scalar. 0 is equal to, this is a vector. That says scalar is equal to vector. That is completely wrong. So therefore, this is not 0. It is 0 vector. Minus 5q. Even now, I take this minus 5q to this side. Right. Then I can write 5q vector is equal to, once I bring this minus 5q to this side, people, that minus will be plus, no? Plus 5q equals 4p vector plus r vector. Right. Now, people, I do another little rearrangement in this. What I do is this. This 5q I am going to write, people, 4q vector plus q vector is equal to 4p vector plus r vector. I will take this side and 4 common, no? Take 4 out. Q minus 4p, no? Once you take 4 out, it is minus p. And take this q to right hand side, r minus p. I think you agree with me. Right. Now, dear students, see here, this q minus p easily come in by this, no? Q minus p, simple q and simple p are the position vectors of the points capital Q and capital P. Then this q minus p is difference of the vectors coming by this pq. Pq vector, how to write? Second letter position vector q minus first letter position vector p. And this also you can write. What's that, people? QR. Second letter position vector simple r minus first letter position vector simple q. We get this way, no? People, what is this? What is this? 4 times pq equals qr. You can very clearly see here, this implies 2 vectors are equal. People, you know, when 2 vectors are equal, the corresponding line segments are parallel. Left hand side line segment is what, people? PQ. PQ is parallel to QR. Here, PQ and this is QR. Here, this Q is common. PQ line, right? And this QR line are parallel. How can this be, people? PQ line parallel to QR line. We have PQ line like this. Another line segment is starting from Q. That should be parallel to this PQ. Then that R should be on the line PQ extended, no? For this QR to be parallel to this PQ, people, PQR should be on the same line. Am I correct? PQ and QR should be parallel to each other. Definitely, people, since there is a common point, for them to be parallel, PQ line and QR line should be on the same line. Otherwise, the two line segments never be parallel. Understood? Then first one, we can say what? This implies PQR are collinear. People, what is meant by collinear? These 3 points lie on the same line. Understood? Right. First thing is that. People, what is the second property, second relation we can obtain by this? Number 2. When two vectors are equal, left hand side length and the right hand side length become equal. What is left hand side length? 4 times PQ length. Right hand side length QR. Now what is asking? A length of line segment ratio, PQ QR ratio. PQ QR ratio. Right. So what is this, people? We can take this QR here or here. This implies PQ divided by QR is equal to 1/4. Ask me what? PQ QR ratio. Correct, no, people? PQ QR ratio. 1/4. We can write this as a ratio like this. PQ QR is equal to 1:4. Understood? That is how, people, we take this answer. Right. Right. People, as the next question, take number 17. Take number 17. Okay. Read the question number 17. Draw the diagram. I'll give 5 minutes. Okay. Yeah, the question says, people, something like this. Number 17. The point P is on AB. The position vectors of capital A, comma capital B relative to origin O are simple A vector, comma simple B vector. Yeah. Point P. Here A is B. Relative to origin O, position vector of point A is simple A. That means OA vector on a simple A. And OB simple B vector. Huh? Right. AP PB ratio. AP PB ratio. M is to N. Where M plus N equals 1. So that the position vector of P is ME plus NB. Right. That's very easy, people. We can take it like this. We can write first A P PB ratio. A to P, P to B. M divided by N. Use this way cross multiplication. N times AP equals M times PB. N times AP. A to P. That means we move along this way. P to B, P to B. You know the same line, same directed directions. So therefore, we can apply vectors on the left and right time segments because of same line, same directed directions. So therefore, this implies n times AP vector is equal to M times PB vector. N time AP vector, people, we can write position vector of second letter minus position vector of first letter. Position vector of P, I am going to take as simple P. That's the usual convention of people. No, if the point is capital P, its position vector is taken as using the simple letter. It's a simple letter, right? And M times PB means, people, second letter is B, position vector is simple B minus that of P is simple P. Okay. Now remove the bracket. N times P minus N times A is equal to M times B minus M times P. You can bring this to this side, this to this side. Okay. So then we get N P vector plus M P vector is equal to, brings right hand side, N A plus B. I can take this simple P vector out, people. Get N plus M simple P is equal to Na plus Mb vector. What is N plus M? N plus M means M plus N, no, given as 1. Then, people, I can put for this N plus M as 1, right? It is nothing but 1 times P vector is equal to Na plus Mb. This implies, people, 1 times P vector means simple P vector, no? Na plus Mb. We get that first answer. Right now, we get that first answer. That is okay. Right. Next question, people. Next part in it. The sides BC, CA, AB or produced. Or produced means extended line. Of triangle ABC are cut by a line at XYZ. Show that this answer. Show that this answer. Okay. We'll take like this. Right. ABC a triangle. Hmm? This is the point A, point B, point C. Hmm? This is cut by a line. I'll take that line like this. Given BC is cut by this line at X, this point should be X. CA cut by the line at Y. BC is at X, CA at Y. This is Y. AB at Z. This way. The sides BC, ABC triangle, BC at X, CA at Y, AB at Z. Right. This way we are given. Because there you are given the sides BC, CA, ABO produced. That means the given sides, if some sides need to be produced to cut by this line, then we are allowed to produce that line. Okay. In one of the three sides of the triangle is cut by this line externally. Understand? So that is why the word produced given there. Right. Now people, I'm going to assume this way. Somewhere on this board, we have the vector origin. Let that be O. To that vector origin O, I am going to take the position vectors of A, B, C points as simple A vector, simple B vector, and simple C vector. And that of X, Y, and Z, I am going to take simple X vector, simple Y vector, and simple Z vector. Right? We will write like that first. Okay? First block diagram, people there. Right, people. Shall we then write the small note? Write down this way. Relative to a vector origin O, relative to a vector origin O, let the position vectors of the points capital A, comma B, comma C, comma X, comma Y, and Z. B, B, E, B. Simple A vector, simple B vector, simple C vector, simple X vector, simple Y vector, and simple Z vector. underline the small letters. Huh? A vector, comma, B vector, comma, C vector, comma, X vector, comma, Y vector, and Z vector, respectively. 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 Right. Now, people, I am going to assume this BX-XC ratio. Also, write down. Also, let Bx divided by Xc. Bx, Xc. 1 is to mu. And Az is B. 1 upon lambda. This way we assume. Ratio we are going to assume. Huh? You know, people, whenever we assume a ratio, there we can use as one ratio figure 1. Now, for example, suppose we have a line segment like this. This line segment is divided by a point C internally in the ratio 2:3. That means this AC divided by CB, 2/3. Even I can divide on the right hand side this numerator and denominator both by 2. Then 2 divided by 2 is 1. 3 divided by 2 is 1.5. See here. Earlier we had two different real numbers without 1 as our ratio figures. But the same ratio we could have written involving one and another value. This way, people, any ratio having two different figures except one, we can express as a ratio involving one and another different number. That thing only, people, I used here. 1 mu, 1 lambda. Okay, fine. That's it now. Okay, no doubt about that. No? Yeah. Now, people, this is what I do. I'm going to write this simple X position vector by using the ratio theorem involving B, C. And here Bx means what, people? Bx is 1, X is mu. This is 1, X is mu. And A is at 1, that is this length is 1 unit, ZB is lambda units. Okay. Then you can write the position vector of the point capital X and the position vector of the point capital Z. Understand? By using the ratio theorem. We'll use the ratio theorem, people, directly here. Because this question was a very old past paper question. Right, people? Those days, in nowadays means long before. We could have directly used what the ratio theorem. Not now. Now many changes available compared to our days and now. Questions are too easier. Syllabus is too short. And number of lessons very low compared to our syllabus. So in nowadays, people, this kind of question is very simple question. This was, I think, very long, very old question, very famous question nowadays, right? Okay, now I'll give you this question to you. Write this simple X vector and this simple Z vector using the ratio theorem involving the position vectors of the extremity points of the line. Right. Then write down simple X and simple Z. Right, by using ratio theorem, start this. by using ratio theorem. Simple x vector you can write how people? Simple x vector you can write 1 into c vector plus mu into b vector. 1 into c vector is c. 1 into c vector plus mu into b vector divided by 1 plus mu. Okay. I'm going to use first multiplication like this. X vector is equal to 1 plus mu times simple x vector is equal to c plus mu b vector. Let us take this as number 1. Similarly, there is a vector we can write 1 into b vector plus lambda into a vector divided by 1 plus lambda. 1 into b means b vector plus lambda into a vector divided by 1 plus lambda. Okay. Gives a first notation to this end. We get like this. Now, I subject the simple b vector taking this lambda to this side. Okay. This vector is equal to simple b vector. That means b vector is equal to this, no? Right. That is simple b vector is equal to this 1 plus lambda times z vector minus lambda. Now, what we do is this. The same thing only people I wrote. Huh? This equals b means b equals this. Now, what we do is people, this b vector we have in number 1 here. I substitute that b vector we are here. Right. Substitute in number 1. Right. So substitute this b in number 1. Get the relation. And now just think how to take the next answer. Okay, people. Then let's see what we get there when I substitute like that. 1 plus mu times x vector is equal to vector c plus mu times vector b. It is 1 plus lambda z minus lambda a vector. Mu times c means 1 plus lambda z vector minus lambda a. Okay. Now, what I do is this, people. I remove the bracket by multiplying this mu. What we get? 1 plus mu times simple x vector equals c vector plus mu times 1 plus lambda z vector minus mu lambda A. Mu lambda A, correct, no? I multiplied, I removed the bracket by multiplying this mu. Mu times 1 plus lambda is Z, plus and minus mu lambda A vector. Okay? Right. Now what I do is this, people. I bring this Z vector to this left hand side. 1 plus mu times X vector. Once I take this side, minus mu times 1 plus lambda Z. We get. And now what is available on the right hand side? C and what is A? Yeah. C vector minus mu lambda A. This is what we get. Okay? Right. Now, what I do next is this, people. I divide both sides by 1 minus mu lambda. By this, we divide both sides. 1 minus mu lambda. Okay. Then you might ask, why? How? Don't ask, wait for a while. Huh? Then this is what I get. Shall I write that here? I need. Yeah. Thing I need. Then I get this one. 1 plus mu times X vector minus mu times 1 plus lambda times Z vector, whole thing divided by 1 minus mu lambda is equal to right hand side C minus mu lambda A divided by 1 minus mu lambda. I'll explain the reason why I divided by this. Once I explain the reason, you never ask the question again. Right. Then shall I erase this whole thing? I think up to here you wrote. Right. Now copy down this. Now copy down this. And after the class, today or tomorrow, people again do the question. This is the period that you are training. That occasion, people don't think that and this. First, understand the method. That is how we can improve the math knowledge. Otherwise, people, if you try to think from the very beginning, going to absolute zero, you have to think from the absolute zero, but not now. Now you have to accept this everything if you can understand. Don't think that and this, and don't pay your attention here and there. Only focus my working. Then immediately you can improve your skills. Don't think anything other than this, right? So then I erase. Okay. Now I am going to explain something about ratio theorem. Suppose like this, we have a point A here, point B here. Point A has a position vector simple A, point B has a position vector simple B. Point C, we have suppose like this. Point C divides this AB line in the ratio here lambda is to mu. Now, how to write by using the ratio theorem the position vector of the point C lambda times A, right? plus mu times b divided by lambda plus mu. People, if this point C lies on the line BA produced, not in between the points B and A. When we produce BA, suppose C is somewhere here. That occasion we say point C divides the line BA externally. Point C divides the line BA externally. The reason is C is not lying between B and A. On the line extended BA, it lies. That occasion, people, this numerator sign, one vector will be negative. We can very easily take that one, right? So shall I take that one now? BC, here I take the same ratio, BC length lambda, CA mu, CA is this is mu. Then this is simple C vector, this is simple A vector, this is simple B vector. How do you understand these ratios? From here to here, lambda unit. From here to here, mu unit. Then from B to A, it is lambda minus mu. Lambda minus mu. Then my purpose is to find the simple C vector, no? Then I think it like this. The original line given is BC. In between B and C, we have a point A. Point A divides BC line internally. Why? A is in between B and C, no? Internally. In what ratio? Lambda minus mu is to mu ratio. Taking like that, using the ratio theorem for the internal case, I can write the position vector of this A. By that, we can subject simple C. I do this suddenly. How? Mu times this B, simple A vector, is equal to mu times B plus lambda minus mu times C divided by sum of the ratios, no, lambda minus mu plus mu means lambda. Then we get here lambda A, bring this side, minus mu B is equal to lambda minus mu times C. Take this denominator, then and subject C, lambda A minus mu B divided by lambda minus mu. See here, when C lies outside of this BA, then position vector of this C come in how? Lambda A minus mu B divided by lambda minus mu. Right now? Okay. People now think in this case and this case, right? In this case and this case, when you consider these 3 points, point A, point C, and point B, these 3 points, people, lie on the same line. That means A, C, B points are collinear. They lie on the same line. Here also, B, A, C points are collinear. Right? The other thing is, people, here, A vector, B vector, C vector. For the simple vectors, the corresponding points are collinear. Whenever you see this kind of vectorization, by this what we get is, people, the points which are corresponding to simple A vector, simple B vector, and simple C vector are collinear. By this also we get that message. Understand? In this case, people, because of this minus sign, what we get is, this C does not lie between A and B. C lies outside of this AB line segment. Understood? Give me 1 second. Now, I was talking with this one. Now, people, remember here, simple A vector, simple B vector involving, simple A coefficient is lambda, Simple B coefficient is mu. The sum of this lambda and mu here we have. That is when this C is in between A and B. When this C is outside of this AB, the relation is numerator and denominator, both we have minus. Okay. Now here coefficient of A is lambda, coefficient of B is minus mu. One coefficient is lambda, other one is minus mu. The algebraic sum of this and this only, what is that? Lambda plus minus mu means lambda minus mu, no? That is available here. Okay, right. Now come to this. People, here we have the coefficient 1 of this C, coefficient is 1. Here coefficient of A is what? Minus mu lambda. Here 1 plus minus mu lambda is what? 1 minus mu lambda. We get this. People, can you tell me, by this right hand side, it explains regarding a position vector of a point. Can somebody think? Nobody will talk with me, no? Right? If you are in the physical class, I can point my finger to you and I can ask the question. At this occasion, I don't know whether you are sleeping. Right? Can you think, right? The point, the position vector, this is a position vector of a point. Can you tell me, where does this point lie? C involving, A involving. Definitely on the line joining C and A. Since in the middle we have minus sign, this point is not in between C and A. On the line CA produced. Therefore, this explains, people, what? A position vector on the line CA produced. On the line CA produced because of this minus sign. Understood? All right. And we will come to this. Here X coefficient is, people, 1 plus mu. To that I am adding Z coefficient, what? Minus mu times 1 plus lambda. Once you simplify there, see what you get. 1 plus mu plus and minus mu minus mu minus mu lambda. This and this we can cancel down. 1 minus mu lambda we have. Here 1 minus mu lambda. But sum of the coefficient of this X and this Z here we have. Then, people, by this left hand side, that also describes a position vector of particular point. Where does that point lie? Since here we have minus, that point should be on the line X position vector, Z position vector. X here, Z here. When we join X and Z points and produce on that line only, people, this position vector extends. Right. This side says, people, regarding a position vector on the line CA produced. This side explains what? Position vector of a point on the line CA produced. This side explains position vector of a point on the line XZ produced. Since this side and this side are equal, what do you understand by that, people? This and this equal mean the right hand side and this left hand side equal mean the point which explains by the right hand side and the left hand side, the position vector of that single point equal. Then people, what could be that point? That point should be people y. Why? It is the point that lies on the CA produced and XZ produced. Understand? This point, for this position vector, there's a point now, people. That point, its position vector and this position vector equal. Position vectors equal mean there can't be 2 points. There should be 1 point. Then this and this both are now describing about 1 point. But this point should be on the line CA produced. This point should be on the line XZ produced. Then for the both case, the point this and this should explain about this point y. So therefore, people, this or this should be the position vector of y. Understand? See the logical, the logic, mathematics logic. Understand? So therefore, this is the position vector of y, and this is also the position vector of y. They are now equal. Therefore, by this relation, people, we can say this equality explains about the position vector of the common point for the line CA produced and XZ produced. Therefore, position vector of point y should be this. Am I correct? Okay. Right. Then after reaching here, we'll write our sentence like this. Write down, people. Write down. This vector equality people, shall we take down another small thing here? This one I can write position vector of a point on XZ produced. What is this? Position vector of a point CA produced. CA produced, right? Yeah. Now we'll write that sentence. Now we'll write that sentence. Write down this vector equality. This vector equality describes the position vector of the point of intersection of the point of intersection of the line CA produced and XZ produced. That is of the point capital Y. That is of the point capital Y. Therefore, simple y vector, what is simple y? Position vector of the point capital Y. It is this. C minus mu lambda A divided by 1 minus mu lambda. Okay, people, now I am going to bring this vector relation to a line. Okay, I don't mind wherever this y lies on the line CA. Really, we know this y lies on the line CA produced, but I draw in a different way the diagram. I draw. People, you know this minus sign is coming because of y is not in between C and A, but I draw so that y is in between C and A. Don't worry, right? See here, position vector is C, and A here, position vector is A. I take somewhere here y. My diagram is really wrong, but never mind. Then I am going to take like this. This one is coming 1 into C. Here 1 into C. And this ratio now I am marking as minus mu lambda. People, this way with the ratio figure minus sign is coming because of this point lies on the extended CA. But I mark like this. Okay. Then once you apply ratio theorem to this to write this simple y vector, how to write that? 1 into C plus this ratio into this. What is that? Minus mu lambda A divided by 1 plus minus mu lambda. Simplify this, what do you get? C plus minus mu lambda A divided by 1 plus and minus. This is coming. What is that, people? The same thing, this no. Then no harm to this statement, though we mark this y in between C and A, because with this ratio we put minus. But actual situation is y is not in C and A. But to get our answer, this is not an obstacle. Okay. Now, people, after marking like this, now we can take what? Asking what, people? Asking A Z ZB CY YA into BX XC. Right. Okay. Now we can write. After marking this way, you can very clearly see CY YA. CY YA ratio. According to this, we can write CY divided by YA. CY is minus mu lambda divided by YA is 1. I think you accept this result I got. This minus is coming because of y is not in between C and A. That is still available here, people, though we have marked this way. Right. Now what I do this way, CY divided by YA, this mu and lambda only I take to the left hand side. That comes to left hand side denominator as 1 upon mu lambda like this. But we didn't bring this minus sign. There we have therefore minus 1. Right. Now what we do is this. This 1 upon mu lambda I write like this. CY divided by YA into 1 upon mu into 1 upon lambda equals minus 1. Correct, no, people? When you multiply these two, really this is coming. What is 1 upon mu? 1 upon mu means Bx upon Xc. Put that there. Cy YA into 1 upon mu means Bx upon Xc. What is 1 upon lambda? A Z B is equal to minus 1. See whether we get the answer. I mean, no, people, we get the answer. This is how, people, we take this answer. I can remember 2-3 weeks before, one student asked a question how to work out this question, put in a WhatsApp message. People, I didn't answer. Why? Do you believe that we can explain this whole thing? No. You must do this kind of questions, people. You must do this kind of question. Then only your thinking ability, mathematical logic, they we have to think, you will get. So do this question again as homework. It's a good question. I'm also teaching this question with very glad nature, because why? There are something to teach to you. Especially here, this equality. By that, the thing we get, very beautiful places in maths. Right, people? That kind of things you should have. Usually, these kind of questions in a class we don't expect to do, because many things there is to explain. Mathematical logic also available there. To absorb this one, people, it takes long time. We have to do as a teacher, must get more effort to give you this. But people, though it is a difficult task, if we can give this one, your thinking ability will be improved very easily. So therefore, do this kind of questions again, right? Yeah. Now we move to another one question, people. I suppose to take the next question as number 16. Take number 16, people. Right? Yeah, no, wait. Before number 16, I am going to another question. You will take number 26, the next. Number 26. I'll give 2 minutes, people. Read this question number 26. Read this question number 26. Hurry up. Right, people. Let's start that question, number 26. The vectors simple A and simple B are two non-zero, non-parallel vectors. When alpha comma beta are scalars, is alpha A plus alpha A vector plus beta B vector equals null vector, then show that alpha equals 0, beta equals 0. This is the theorem we proved, no, people? We proved this theorem, right? This first part in the theory class, the theory, under theory we have done. So therefore, no need to do again that part. We have done that one. So therefore, we'll skip that part, right? Okay, we'll come to the next part. Vector OA given as simple A vector. Vector OA is simple A vector. Vector OB is simple B vector. C is a point such that OC vector is equal to A plus B. This is the important part of the question. Right, people, now suppose here vector A is this. This point is A. This vector is OA. Vector B this. This is simple B vector. Point C is so that OC vector is equal to vector A plus vector B. People, where should be the point C then? Point C should be such that OACB is a parallelogram. Then only OC will be A plus B vector. Understood? If you don't understand this, people, after that you can't work out this question. So therefore, the point C is such that OC vector is A plus B, no? Then the point C should be the next vertex of this OACB parallelogram. So see here, when I construct this parallelogram, this way, this length and this length being equal because this is a parallelogram, right? This is a parallelogram. Huh? Yeah, it will change this. Huh? Right. This and this sides are equal. They are parallel. Therefore, this OB vector is equal to AC vector. Therefore, this is simple B vector. When I join this O and C now, OC vector we can write by using the triangle law of vector addition OA plus AC. It is simple A plus simple B, this one. So that is why we say the point C should be such that OACB is a parallelogram. Understand? Right? Then it's okay. OACB is a parallelogram. Parallelogram, right? Okay. Now we'll read the next part. P is a point on BC. Yeah, somewhere here. P is the midpoint of BC. Yeah, P is the midpoint of BC. Midpoint means the ratio is 1:1. Show that OP vector. OP vector is OP vector. We have to take this as the answer. Right. We will have to take this OP vector. OP vector you can write by using the triangle law of vector addition. OP vector is equal to OB vector plus BP vector. Right? Then you can write OP vector is equal to OB vector plus BP vector. If P is the midpoint of this BC, then how do we write this BP vector? You can write BP vector as half BC, half BC. Understand? Half BC. OB vector plus half BC vector. Why? Because P is the midpoint. OB vector, people. OB vector is B, right? Half BC vector, B to C vector is equal to O to A vector because this is a parallelogram. Therefore, BC vector simple A. You can see whether we get this answer. Yeah, we get. No. Take common denominator as half. That means common denominator as 2 people. 2 and this B we have to multiply 2B plus A. This 2 I can write as half taken out from a bracket A plus 2B vector. This is the OB vector. This way the first answer is coming. Right? Yeah. Right. Now, people, if the line OP meets AB at R, line OP meets AB at R. When I join A and B, AB and OP meet at R. This is the point R. Right? Yeah. Now asking, show that RB, this vector, RB vector is equal to my B minus K times A plus 2B, RB vector. Okay, RB vector. How to write RB vector? People think how to take this. RB vector we must write B minus K times A plus 2B. Yes. You accept this OR vector we can write as a portion of OP vector. Am I correct? OR vector I can write as a part of OP vector. That you agree with me? So then I write like these people. OR vector we can write lambda times OP vector. You agree with me? This OP is longer than this OR. So therefore this lambda should be less than 1. Lambda is a positive real number which is less than 1. Understood? Right? Now RB vector you can write people by using the triangle law of vector addition. How? RB vector is equal to RO vector plus OB vector. Understood? Right. Now RB vector is equal to RO vector plus OB vector. RB vector is equal to OB, this one I write first. RO people I can write minus OR, no? We know once we interchange the order of the letters, minus sign coming out. This way I can write. RB vector you can write. OB. OB vector, OB vector, simple B vector. OR vector is lambda OP. Lambda times OP. But we found this OP vector where here half A plus 2B. B minus lambda times OP vector half A plus 2B. This one I can write lambda into half means lambda by 2. B minus lambda divided by 2 A plus 2B. People, this lambda divided by 2 part I am going to take as K. Let lambda divided by 2 equals K. For lambda divided by 2, I take as K. Then we get the asking answer there. Therefore, RB vector is equal to B vector minus K times A plus 2B vector. This way, we can take that answer. Right. Now, next one asking, what's that? Shows that AR-RB ratio is 2:1. AR RB ratio is 2:1. Yeah. Then I am going to assume like this. This RB we have. Right. Now I am going to assume this way, people. Let AR divided by RB 1 upon lambda. This way we assume AR is to RB ratio. I am going to assume as 1 is to lambda. Then I can write people this way. If we take A here, R here, and V here, according to this assumption of the ratio, this says if AR is 1 unit, RB is lambda unit. People, then can you write this RB vector as a part of AB vector? Yes, possible. RB vector we can write. Therefore, this R to B vector, when you put the arrow like this, we get RB vector. RB vector we have to write. Now we can write really as a fraction of AB vector. People, can you tell me how to write this RB vector as a fraction of AB vector? AB vector we must divide by the sum of the ratio figures. What is the sum, people? 1 and lambda. Sum is 1 plus lambda. Since we need RB, for this RB, what is the corresponding ratio? Value? Lambda. By lambda, we have to multiply. You know this before. Understood? But people, how to write this AB vector? AB vector, we know how to write. Second letter position vector minus first letter position vector. So therefore, we can write RB vector is equal to lambda times B minus A vector divided by 1 plus lambda. I think up to there it is clear. Okay. Now people, first part now you can do what? Here we have RB vector. Here also people we have RB vector. The same RB vector we have found in two ways. Therefore, this right hand side and this right hand side must be equal. You have to recreate them. Then in the left hand side and right hand side, you have in simple A vector and simple B vector. But what are these simple A vector and simple B vector, people? Simple A vector is this, simple B vector is this. They are two non-zero, non-parallel vectors. People, can you remember? We did one theory. When A and B are two non-zero, non-parallel vectors, and when this simple A vector and simple B vector satisfy this kind of vector equation, people, we said what? This A coefficient is left hand side should be equal to right hand side simple A coefficient. This simple B coefficient in the left hand side should be equal to right hand side simple B coefficient. Doing that way, people, obtain two equations. In that two equations, as your unknowns, you will get K and lambda. Solve in that two equations, people, find lambda. Then this lambda will be, people, AR, RB, no? Lambda will be half. If lambda is half, the next answer is coming. Understood? I'll give you 2 minutes. Try this, people. What? Equate this right hand side to this right hand side. Then equate left and right coefficients of A and coefficient of B separately. Take two equations. They are two simultaneous equations with the two unknowns lambda and K. Solving them, find, people, lambda. Lambda will be half. Then you get the last answer. Right. I think you can do this, people. Right. Start. People. Yeah. Let's see. Is this all right? And now write equating RB vectors. What do you get? Lambda times b minus a divided by 1 plus lambda is equal to people that b minus k a plus 2b vectors. Now we have to first find the coefficients of a and b left and right. For that, what we do is by this lambda we multiply this b, then lambda times b, but we should divide that by 1 plus lambda. 1 plus lambda. Then the coefficient of b going to be this thing, right? Except the b later the rest. This time this we multiply. A plus a minus lambda a, but divided by 1 plus lambda. Then the coefficient of a going to be except this a, this part. This sign also we have to take. Minus lambda upon 1 plus lambda is the coefficient of a in the left hand side. Now on the right hand side. Now I erase this. No longer we need this diagram. B minus k times a minus plus minus 2kb. Right. This b and this b we take together. This b has a coefficient 1. We open a bracket 1 b. This b we take out. Here we have 1. Okay. We take this b out. Then here we have 1. No? Right. When you take this b out, minus and 2k we have. And here minus k. And this is now lambda divided by 1 plus lambda times b minus lambda upon 1 plus lambda times a. Now we can very easily equate the coefficients of simple a vector and simple b vector in the left and right. Equating simple a vector, what do you get, people? I write that here. Left hand side simple a vector coefficient is with this minus sign lambda upon 1 plus lambda. Minus lambda upon 1 plus lambda. Right hand side it is minus ka. Therefore, coefficient is minus k. Except the simple a letter, the rest minus k. Even this minus signs you can cancel down. Lambda upon 1 plus lambda is equal to k. Let us take this as number 1. Now, secondly, I equate the coefficients of b in the left and right. Lambda over 1 plus lambda is equal to this, people. 1 minus 2k. Right. Now, people, how to take this? Lambda only we need to take, people. I will take this as number 2. No need to find this k, right? We need only lambda. Then what we do, people? This k given by number 1, we substitute where here. And we get an equation only involving lambda. By solving that, you can find lambda, right? Now try that, people. Substitute this k. What is k? K equals lambda upon 1 plus lambda, no? That we substitute where here. Right. Then you can write that also. substituting 4 k number 2 by number 1. What do you get? Lambda upon 1 plus lambda is equal to 1 minus 2 times. People, what is this k? But what is k? Lambda upon 1 plus lambda. Right. When we have this kind of equation, to find lambda here, people, the denominator, this 1 plus lambda and this 1 plus lambda denominators can easily be removed. Multiplying both sides by 1 plus lambda. Multiplying both sides by 1 plus lambda. When you write 1 plus lambda here, this 1 plus lambda we can cancel down with this 1 plus lambda. And this is lambda now. And when you multiply this 1 by this 1 plus lambda, this is 1 plus lambda. And when I write this 1 plus lambda, just after this 2, here we get 1 plus lambda, that 1 plus lambda, and this will cancel off. And now here we have 2, and here we have lambda minus 2 lambda we get. Okay, people. Then once you people take this lambda to this side, this lambda when you bring to this side, that will be minus lambda. Lambda minus lambda is 0. Okay. Then lambda bring this to this side, minus lambda, bring this 1 also to this side, minus 1. Now on the right hand side we have minus 2 lambda. Okay. Lambda and this lambda we can cancel down. Minus 1 is equal to minus 2 lambda. Divide by minus 2. What do you get? Minus 1 divided by minus 2 is equal to minus 2 lambda divided by minus 2. Then you can cancel down here, people. Minus 2 with minus 2, minus minus plus lambda. This half equals lambda. Half equals lambda means lambda equals half. Lambda equals half. We need to prove, people, ARRB 2 is to 1. No. Now that value we found is lambda, we put pair here. Then we get the next answer. We get the next answer. Right. Therefore, you can write. Now, AR divided by RB is equal to 1 upon lambda. People, what is lambda? Lambda is half, no? Put that ARRB, lambda is half. This is how we write. Suppose this lambda half. This 2 goes to here. AR divided by RB 2 by 1. ARRB equals 2 by 1 means AR is to RB ratio is equal to 2 is to 1. This implies AR is to RB ratio is equal to 1. This way we get that down. Right now, that's how we take that down. Well, we'll do another one question more, no? Now 10:30, 10:35. All right. And the next question, people, we take number 16. Question number 16. Take question number 16 as the next. take this answer in number 16 people. To take the answer in number 16, you should know a certain geometrical property relating to a triangle. Here I am going to take a triangle. For the convenience of explanation, I take right angle triangle like this. For the easy explanation, people, I am going to take right angle triangle. You know, right angle triangle obeys Pythagoras theorem. When I take people this as 3, this as 4, the hypotenuse is going to be 5. People, now the first property regarding this triangle, question number 16 people, 16. First property you should know, people, this. When we consider any triangle, its sum of any two sides is greater than or equal to the third side. Now suppose here, we take this side and this side, 3 and 4. Then the next one is the third side, it's 5, no? This 3 plus 4 is 7, 7 greater than 5. Understand? What is that? First thing you should know, the sum of any two sides of a triangle, the sum of any two sides of a triangle is greater than or equal to the third side of the same triangle. Greater than or equal to. This is, people, the greater than case. How does this equal case occur? People think like this. Now I am going to draw a triangle like this. To draw the triangle, I will take something like this. A certain technique I take here to draw the triangle. Suppose this is a circle, right? Radius is this O. I draw a triangle like this. Right. A, O, A, this is P. Right. Now, I produce this line OA like this. It cuts this circle here. Now, people, what to do? What we do next is, we bring this point B along the circle like this. And keep drawing the triangle. Once this B is coming along the circle like this. This way, you know. Here. Here. Right? Like that, when this point B is coming along the circle like this, people, one occasion, this point B coming along the circle will come to this point. Understand? Then what can you say? This side OA, that AB side now will be equal to this. AB side will be equal to this. Now OA plus AB, B is now here, no? Will be equal to what, people? OB, no? Right? When the B is here, OA plus AB, OA plus AB greater than OB. Sum of any two sides of a triangle is greater than the third side. Now, once I bring this B point along the circle like this, one occasion the point B comes onto this. That occasion, people, we get a straight line, not a triangle. Straight line is a triangle, people, with zero area. Straight line means, people, straight line means a triangle with what property? Zero area. So once the point B comes along the circle and comes on to this point, people, OAB will lie on the same line. Then OA plus AB sum exactly equal to OB, no? That's the people next case. Therefore, in general, we write what? The sum of any two sides of a triangle greater than or equal to third side of the same triangle. Understand? And the other thing is number 2, here we can write that this equal sign in this case not valid, greater than sign only valid. Second one, okay, difference of any two sides, difference of any two sides of a triangle is smaller than or equal to its third side. See here, in this triangle, I take 4 minus 3, difference of any two sides. The next one is 5, no? What can I say about this difference? It is smaller than 5, no? This is 1, no? 4 minus 3 is 1, no? And take this and this as a difference, 5 minus 3. The other side is 4. 5 minus 3 is 2. 2 less than 4, no? And equal to also possible. Even I take like this. See here, we have a triangle like this ABC. You see. Then when we apply here, this one AB is one side, I take BC. Difference of any two sides of a triangle smaller than the third side. AB took, BC took, then AC. Now this can be equal. The left and right can be equal. That location takes place this way, people. I bring this point C like this, people. I bring this point C like this. Once we bring the point C like this downward, people, one location, the point C will be coming to here. Then no longer this triangle, we get there. Instead of the triangle, we get a straight line when the point C comes on this AB. Because straight line means what? A triangle with zero area. That's how we define in maths. Understand? Once you bring this C onto this, people, here we have now C. Now look at the diagram. AB is this whole thing. From that we subtract BC, this thing. From this whole thing, we subtract this thing. What is the answer? It is now equal to AC. No? Understand? So therefore, the second thing you should know is, people, the difference of any two sides of a triangle smaller than or equal to third side. That two laws, people, you must know. Understood? Right? Yeah. And then we'll write this as a note under question number 16. Note number 1. Write down note number 1. The sum of any two SUM sum, the sum of any two sides of a triangle is greater than or equal to its third side. Its third side. Number 2. Number 2 people. Second one right now. The difference of the difference of the difference of any two sides of a triangle, any two sides of a triangle is smaller than or equal to is smaller than or equal to its third side. Its third side. Right. Even now, I think subject to these two notes, I think you can take this answer for question number 16. Right? Do that as homework. If not, next day at the beginning of the class, I discuss this question. Now, people, all the questions up to question number, right? Yeah. As I told you previously, 47 you can do 5 questions. Next day I do another 2-3 questions and I come to our new theory part. Understood? Okay. Right. Then this is the questions required to discuss to work out the rest questions. Right, people? Now, question number 32 and 33. Except this 32 and 33, the rest questions up to 47 you can do. 32 and 33 only. The next time new theory I am going to discuss. Right? And thereafter, another new theory in the same lesson we have discussed. And thereafter, another new theory. Right? In your vector lesson also, people, this is a very long lesson. But in combined maths, some parts of the vector lesson also dropped. In nowadays, people, we had this vectors we learn. Another one called as vector dot product that you have to discuss next. And vector cross product that in your syllabus just to explain only. In nowadays, we had vector dot product, vector cross product, vector triple product. Like that, we had 3 new, except your syllabus, we had to discuss those questions also. Very long area in the vectors, and there were 3 questions under vectors in the paper, 3 or 2 questions, right? So not like this combined. People, in nowadays we had 4 papers, 4 papers, 2 papers for pure maths, another 2 papers for applied maths. For the pure paper, people, we had to 12 questions. There were 12 questions and we had to answer 6 questions. Then altogether in 4 papers, people, there were 48 questions. Just think, to give 48 questions, people, how should be the length of the syllabus? But in your altogether, in both the pure and applied syllabus, people, you have only 28 lessons altogether. Right? So nearly half of the syllabus is cut down. For that syllabus, you can very easily take A-pass, people. Not that much deeper questions asking nowadays. But still the people, they get F for maths. What to do, people? That is because of the error. The fault is teachers. Teachers, they just do here and there, especially some tuition masters. In order to keep the students in the class, they do very simple sums and keep the student nice position, comfort position. Student think, oh, this is the maths. Our teacher is the best. We can understand everything. But at the examination, with the things he or she has understood in the class, that is not enough to answer the questions at the paper, even though the questions are too simple. Therefore, people, this is the time we practice. We have to do bit harder questions. More harder questions available in the tute. That hardness you must understand yourself by doing the question. If I teach that one here, people, you never get that hard feeling in the question because I try to give you this in the most simplified way. That occasion you will understand, no, this is not that much difficult. But people, when you do the question yourself only, you will realize this question is hard. Hard means, people, not hard really. The points to work out the question, you won't get advanced to your mind. That's the reason. That's the hardness you get as the hardness. No, people, not hard. Nothing available called as hard. Only thing is you are not ready to accept that one. Something is lacking. You miss something. That's only, people. By finding that what are the errors inside me, you have to fill. For that only you must do questions yourself. Otherwise, people, nobody can improve any area. Okay, so therefore this question try as homework, and some try to do as homework. And I take another 5-6 classes in vectors. Don't be hurry, people. For the hurry people, they have some other classes. Go those classes and learn. I don't hurry that much. We know how to do this one, right? So I need your A pass, not the S pass or failed students. There will be failed students because they are not working with. Nobody can get without working, people, the most valuable things. No, nobody can reach what most valuable things to their lives without giving effort. Understand, right? Do something come in without giving any effort, people, that is worthless. Nobody will keep that alone time with them, those worthless things. So therefore, education is something like that. Okay, then we meet next day, people. I stop the class here. Next Friday evening again we start. And if somebody couldn't understand this one today, please get the recording and watch that again. Before that, you have to send me your email address to the email address only, people. And now I offer the recording. Okay, then people, we come to the end of the project class. We meet next Friday in the evening 8. And your physical classes, we are starting, as I told you at the beginning of the class, 12th Sunday morning 8 o'clock Kurunagala, and 11th Saturday morning 7:30, 7:45 in Kandy IMS. From new lesson, we start the physical classes. And until you finish this lesson, definitely you have to follow this Friday evening class. Otherwise, I am not going to do this lesson we are in that physical classes. Understood? Okay, people, I don't think that you have a question. You might have questions, but you are not the person to ask that question at the moment. If you have questions, we'll discuss them later. Okay, people, then nice day. Good night to everybody. We meet next week.